Welcome to my channel. Today I'm going to show you how to turn this into this. This is a version of the Creality Touch Screen for the Ender3 Pro sold by First Layer, but I don't find it very practical, so I have designed this simple one along with this mount. This is just an adaptation of the Nebula pad mount. Now I will just insert the case like this, and the mount will be placed on the printer using these two holes at the bottom. Here are the different parts. This is the main box with the openings here for the SD card and here for the cable connect and the buzzer. As you can see at the back, I have written the labels for the different pins of the cable connect. Here we have the serial number of the touch screen. And this is the top part. Here we have 4 holes in which the screws will be inserted. And I will place it just like this, and then put the screws from the bottom here. Now after that, all I need is to screw the mount on the frame and then place the screen like this. Now I will need to remove this bulky metal part, and for that I will just have to remove this black sticky tape here. I will use a hot air gun for that. First I will remove these screws. Now I'm going to heat it. There it is. My screen is here. Now I put it in the box here. This is the connector that comes here. Now I put the top part. Okay, now I can put the screws. Okay, here it is. Now we're going to install the mount. Now I open Fusion 360 and I create and open a new file. Now to make it easier to remix, I will use some parameters. So before starting the sketch, I'm going to into the parameters. I go to modify, I click on change parameters and I click here to add a parameter. The first parameter is the angle. I will call it angle. The unit is in degrees and I put 50 degrees. The next parameter is the thickness is 3 millimeters. Next parameter is the gap, that is the gap between the different parts to make it easy to slide. I'll put 0.5 millimeters. You can change it according to your own printer. The next parameter is the box height. That's 21 millimeters. Next parameter, box length. Is 128.9 millimeters. Next, we have the box width. That is 80.2 millimeters. Now we have the mount length. That is the length of the mount from the bottom to the top. I put 60 millimeters. Now we have the mount width, which is equal to the box width plus 2 times the thickness times 2 plus 2 times the gap. This is what we have. Suppose this yellow area is the screen itself, the box. This is the width of the box, that is 80.2 millimeters. Now when I insert it in the mount, I need a certain gap here with the shown with the red line, that is 0.5 millimeters. And now we have the thickness of the mount here, that is 3 millimeters. Now to have the full width of the mount, we need the width of the box plus 2 times the gap, that is on the left and on the right, and 2 times the thickness also on the left on the right. That makes it 87.2 millimeters. This is for the mount width. Now we add the mount height. It is equal to the box height plus 2 times the thickness plus 2 times the gap, that is 28 millimeters. Here also, if you look at the picture, here we have the box and the height is 21 millimeters. Now for the mount also, here we need this gap, that is 0.5 millimeters, and the thickness, that is 3 millimeters. So for the total height of the mount, we have the mount of the box, that is 21 millimeters, plus 2 times the gap, plus 2 times the thickness, that is 21 plus 2 times 3 plus 2 times 0.5, that is 28 millimeters. Now we have the mount inner height, that is the internal height of the mount, and that's equal to the box height plus 2 times the gap. So let me show you here. Here we have in brown, we have the mount. This is the total height of the mount, and this is the thickness of the mount, that is 3 millimeters. In the middle here we have the box with 21 millimeters of height. Now when I insert the box in the mount, we need a gap between the two, and this gap is 0.5 millimeters. The height of that shell, that is the blue part here, will be equal to the height of the box, that is 21 millimeters, plus 0.5 times 2, and we have 22 millimeters. So I give all these parameters to make it easy for you. That is, when you change one of the parameters, you will change all the others. That is, for example, if you decide to use a thickness of 2 millimeters instead of 3 millimeters, you will automatically have the height of the box, the widthness, and so on. All those elements will change at the same time. Now we have the rib plane, that is the height of the rib. I will show you later what the rib is, and this is equal to the length of the mount divided by 2. Now we have the diameter of the screw, that is 3.3 millimeters. We also have the diameter of the screw heads, that is 7 millimeters. We have the display mid length, that is 108 millimeters. We have the display mid width, that is 68.5. We have the display inner length, that is 97 millimeters. We have the display inner width, that is 56 millimeters. We have the distance between the inner line and the midline of the display from the right, that is 9 millimeters. We also have the distance between the midline and the outer line on the right of the display, that is 2.35 millimeters. Now we have the cover height down, that is 7 millimeters. We have the cover height at the top, that is 2 millimeters. We have the diameter of the mount screw, that is 6 millimeters. We also have the longer distance between the screws, that is 40 millimeters. We also have the shorter distance between the screws, that is 20 millimeters. We have the distance between the screw and the mount, that is 7 millimeters. Okay, now we have finished entering the parameters. Now we're going to start the sketch. Now, before going further, I will show you a very interesting feature that will make the parameters more effective. That is the use of if statements in the parameters. Now, if you look at this, if you look at the mount, you see here the rib is at the middle of the length of the mount, and the screw hole is totally free. But if I change the angle, suppose I put here 30 degrees for the angle, as you can see, the rib is very close to the hole, and the hole itself is covered by the mount, so it's no longer possible to put a screw here, and I don't want that. Now the main solution is to move this rib upwards a little bit. Also, I don't want to have the mount of the screw hole. I want to have a minimal angle below which I cannot go, so I want to limit the angle. And after a number of tests, I've noted that the minimum angle I can have is 40 degrees. So let me put here 40 degrees. There we go. Okay, as you can see, with 40 degrees, that's what we have. We still have the screw that is free on the side of the mount here, but the rib is still almost overlapping with the hole, and I don't want that too. Now what I can do is limit the possibilities of the angle, the minimum angle, limited to 40 degrees. That is, I cannot have less than 40 degrees. But also I would limit the maximum angle I can have. For example, I can limit the angle to 90 degrees for the tilt, or let's say 80 degrees for the tilt. So it means that the angle should be between 40 degrees and 80 degrees, not more than 80 degrees, not less than 40 degrees. Now to do so, I go to the parameters. Here I have the angle, but I need another parameter that will control the angle. Now for that, I will create a new parameter. I will call it, for example, for angle. I remove the units. It should be no units. It should be no units here. I put a value, maybe for example 50, and I click OK. Now this is the parameter here. Now it is this parameter that I will use to control the angle here. Now for that, I will use the if statement. I click here in the expression field and I type in if for angle is inferior to 40, semicolon, I put 40. What does it mean? It means that if the value I put in the parameter for angle is inferior to 40, the angle will be automatically put to 40. Now I continue, then semicolon. Now I will put the maximum limit, that is 80 degrees, and for that I type in if for angle superior or equal to 80, semicolon, I put 80. It means that if the parameter for angle is superior to 80, the angle will be put automatically to 80. Now the other alternative, I put for angle. It means that in all other cases the value of the angle is equal to the value we put in the parameter for angle. Now I can close and I click OK. There it is. Now as you can see here, the value of the angle is 50. Now let's change and put a value inferior to 40. Let's put, for example, 30 here. I click OK. Now if you look here, the angle, the value is automatically put to 40 because I have chosen a value inferior to 40. If I put, for example, another value that is superior to 40, let's say 50, I click OK. If you look here, it takes the same value as for angle because it's beyond the minimum angle and below the maximum angle. Now let's put, for example, 90 degrees here. I click OK. As you can see here, for the angle, the value is automatically put to 80. That is, it cannot go beyond 80. And as in for angle we have put 90, that is the maximum, over the maximum angle we mentioned, it remains to 80. It cannot go beyond 80 degrees. Now when we come back to the minimum angle, let's put 40 here. Here, as you can see, as I said, the rib is very close to the screw hole, so I need it to move a little bit further. Now for that, what I'm going to do, I go back to the parameters. Now I look for the parameter rib plane, that is this parameter that handles the height of the plane on which the sketch of the rib is drawn. Now here what I'm going to do, I want the rib. Okay, let's come back to the picture. If the value is inferior or equal to 40 degrees, I want the rib to move a little bit further, that is about 70% of the height of the mount here, about this position. Now if the angle is superior to 40, it can be at the middle, it doesn't matter. But if it is inferior to 40, the rib will move a little bit further. Now for that, I open the parameters, I go to the rib plane, and I type in if angle is inferior to 40, if angle is inferior to 40, semicolon, the position of the rib plane is equal to the length of the mount times 75%, that is times 75 divided by 100, else it is equal to the height of the mount divided by 2. I close the statement and I hit OK. Now let's see how it works. Okay, as you can see here, the rib has moved, the position of the rib has moved about 75% of the height of the mount, that is here, because the angle is equal to 70, because the angle here is equal to 40. Now if we change the angle, let's put for example 60 degrees, let's put 60 here. I click OK. Okay, as you can see, the rib is at the middle of the head of the mount here. It does not go beyond. This is very interesting because in any case, whatever the angle, I always have my screw hole that is free. There is no overlapping with the rib or the mount itself. So as you can see, this is an important aspect of the if statement in the use of the parametric designs in Fusion 360. First I show the origins. I select angle plane. I select plane at angle. I click on the x-axis, and for the angle I choose my parameter angle, that is 50 degrees. I click OK. Now I can create a sketch on this plane. I draw a rectangle. I make the bottom line coincide with the center here. I make these two lines symmetric. Now for the measures, now for the length. For the height, I type in, I choose box length in the parameters, that is 128.9 millimeters, and for the width I choose box width, that is 80.2 millimeters. Now I finish the sketch. I select extrude, and for the extrusion I choose in the parameters box 8, that is 21 millimeters. I click OK. And now I choose shell. I click on this face and I select my parameter thickness. I create a sketch on the bottom face here. I draw a rectangle. Now between this line and the edge, I type in 17.8. Between these two lines, I type in 23 millimeters. Now for the height, I type in 10 millimeters. I finish the sketch. I select extrude, I select this face, and then I type in -12. I select cut and I click OK. Now I create a sketch on the bottom here. I select project. I choose these lines. I click OK. Now I can add the body. I remove the outer line. Now I draw a center line here. Another one here. And I make them construction lines. Now I draw a rectangle here. I draw a tangent arc. Now I remove this line. For the height here, I type in 10 millimeters. For the distance between the line and the center, I type in 12 millimeters. And between the circle and this line, I type in 17 millimeters. Now I draw a circle here. For the distance, for the diameter, I select my screw diameter in the parameters. Now between the circle and this line, I type in 4.10 millimeters. And between the circle and this line, I type in 4.05 millimeters. Now I draw another circle. The distance between the two circles, I type in 5 millimeters. I draw a vertical line here. Then a horizontal line here. And I make buffer lines tangent to the circle. I trim this part, also this part, and this small line here. And now I can remove this one. Now I select the mirror. I choose the circle and all these lines. For the mirror line, I select the center line here. I click OK. I choose mirror again. I select this circle, all these lines, this second circle, all these lines, and for the mirror line, I select this line here and I click OK. Now I can finish the sketch. I show the body again. Now I click extrude. I select this part and all 4 circles. Now I click at the bottom. Now I select extrude again. I select this face, this one, and this one, and I type in 6 millimeters. I select join and I click OK. Now I create a sketch on this face here, the support of the screws. I draw 4 circles. I make them equal. And now for the diameter, I choose in the parameters screw head, that is 7 millimeters. Now I can finish the sketch. Now I select extrude. I select these faces, this circle, the 4 circles, all 4 circles. For start, I select offset and I type in minus, and I choose in the parameter the thickness, that is -3. Now for distance, I select object and I click at the back here, and I make sure that here I have cut, and I click OK. I create another sketch on this plane here. I have already the text in another sketch, so I'm going to copy and paste it. Select these elements and this one. I select copy. I come here and I paste. I finish the sketch. I select extrude. I select all the text here. I type in 1 millimeters. I make sure that I have cut here and I click OK. Now we are done with the box. Now I create another component. I will call it cover. First I'm going to create an offset plane. I click on the top of the box here and I type in -2 millimeters. Now I create a sketch on this plane. I choose project and I project this line here. Okay, now I can hide the first component. I can remove the outer line and I make this line construction lines. I draw a center line here, another one here. I make them construction lines. I select offset. I select these lines and I choose in my parameter the gap, that is 0.5. I click OK. Now I draw first rectangle. I make these 2 lines symmetric. Now between this line and this line, I select the distance without a line in the parameter, that is 2.35 millimeters. Now For the length of this line, I choose the parameters display mid length, that is 108 millimeters, and for the width I choose the parameter display mid width, that is 68.5 millimeters. I draw another rectangle. I also make these two lines symmetric. Now the distance between these two lines, I choose in the parameters the distance in the mid right, that is 9 millimeters. For the width here, I choose display inner width, that is 56 millimeters. And for the length, I choose in the parameter display inner length, that is 97 millimeters. Now I draw another rectangle here. I make those two lines symmetric. Between these two I type in 20 millimeters, and for the height I type in 5 millimeters. Now I draw two other lines here. Between these two I type in 20 millimeters, and between these two I type in 20 millimeters. Now I can finish the sketch. Now I select extrude. I select this part, and in the parameters I choose minus cover height down, that is -7. I choose again extrude. I select this part, and these two spaces, and I choose in the parameters cover height top, that is 2 millimeters. Now we need the hole for the screw. For that I come back to this sketch here. I display the first component. I select project, and I click on this circle, this one, and this one. Okay. Now I show the sketch. I had the body. I select extrude, and I choose the 4 circles. Now I show the body, and then I click on the face here. Okay. Now we're going to add the threads. I select this hole, modeled, remember the size. Okay. I do the same for all 4 holes. And there it is, the cover also is done. Now we're going to design the mount. I create a new component, and I call it mount. Now I create a mid plane. I click on this face and on this face. I create a sketch on this face. Now I display the box. I select project, project the bodies, and I choose this one. Click OK. I can hide the body. I can remove this line, this rectangle, this circle, and also these elements here. Now I make these lines construction lines. I select offset. I choose these lines, and here I choose the gap minus the gap, minus the thickness. And that's 3.5 millimeters. I select offset again. I select these lines, then I tap in minus the gap, that is minus 0.5. Click OK. Now I draw a line here. Then I trim this part, this line, this one, and this one. I can remove these lines. Now for the distance between this line and the bottom, I select in the parameters the height of the mount. That is 60 millimeters. I also select fillet. I click here and here, and then I type in 4 millimeters. Okay. Now I can finish the sketch. I select extrude and I select all the parts. For the direction I choose symmetric. For the measurement I select whole length, and then for the length here I choose in the parameter the mount height, that is 28 millimeters. There it is. I show the sketch again. I had the body. I select extrude again. I select this part in the middle. I show the bodies. For the direction I choose symmetric. For the measurement I select a hole. And for the distance I choose in the parameters. I choose in the parameter the mount in a height. Then for operation I select cut and I click OK. There it is. Now I create a sketch on this face. Now I show the cover. I select project and I project the cover. I click OK. Now I can add the cover. I can add the body, and I remove this outer line. Now I can finish the sketch. I select extrude, I select this part, and I go and click at the bottom here. Now before going further, I will copy this body. I select copy here. And I move it to the other side. Now I hide this second body, then I create a sketch on this face here. First I draw a triangle like this. I make the lines construction lines. For this distance I type in, for this distance I choose in the parameters longer distance between the screw, that is 40 millimeters, and here I choose in the shorter distance between the screw, that is 20 millimeters. Now I draw 3 circles. I make them equal. Now for the diameter I choose the mount screw diameter. Between this circle and the mount I type in 7 millimeters. I choose in the parameters distance screw mount, that is 7 millimeters. Now I draw a line starting from here. I move forward. I can connect here. Now between those two lines I choose the same distance, that is 7 millimeters. Also between these two lines, now between these two lines I type in 36 millimeters. Okay, I choose fillet. I select this part, and I type in 4 millimeters. Now I can finish the sketch. I select extrude. I click here and I type in minus thickness -1, that is 4 millimeters. Now I display the second body. I also display the sketch. Okay, now I click extrude again. I select this part. For the start, I select object and I click on this face here. And now I type in thickness +1, that is 4 millimeters. Okay, here we have our two bodies. Now I create an offset plane. I click here, and for distance I type minus, and I choose in the parameters rip plane. Now I create a sketch on this plane. I select project. I click on this body and on this one. I can hide the bodies. I'll draw a line here. I make it a construction line, and I make it symmetric between these two lines. I draw a line like this. I choose fillet. I click here and I tap in 4 millimeters. Now between the circle and here I type in 7 millimeters, and between the center of the circle and here I type in 4 millimeters. Now between the center of the circle and this line here I type in 7 millimeters. Between the center and this line I type in 4 millimeters. Now between this point and this point I type in 15 millimeters. Now I select mirror I click on this line. Now for the mirror line, I select this one and I click OK. Now I can click finish. Now I can finish the sketch. I show the bodies. I click extrude. I select this one and this one, and for the distance I type in thickness +1, that is 4 millimeters. I select join for operation. I click OK. Now I choose fillet. I select this line, here, here also, here, and here, and I tap in 2 millimeters. I do the same on the second one. I tap in 2 millimeters. Okay. I just fill it again. I click on this face and on this face, and I tap in 2 millimeters. Okay. Now we have the left mount and the right mount. And this is our new case with the 2 mounts, one for the right and one for the left. As you can see, I have added this PDF file in which you will find all the information in relation to the design. You have the measures, the extrudes, etc. Here we have the table of content. We see, for example, here the user parameters, the main box and all the elements of the main box. Here we have the cover and all its elements and so on. If we click on user parameters, for example, we come to these pages on which you can find all the parameters that I have used in the design. And here we have the sketch one. We have the dimensions. Here we have the extrude number 1 with all the dimensions. We have the shell 1 also, and we have sketch 2 and the position. You have all the sketches that are in the design, the extrudes, the shells, the planes, and so on. It may be very useful for those who want to remix the design themselves.